Hello students. In the previous class we have gone through the equality of the complex numbers. I am repeating that for those they have not taken the consideration. So, and it was let z is equal to x plus iy and x plus iy is equal to 3 plus 4r. Then we can write down x is equal to 3 and y is equal to 4. What that means? We are equating real to real and imaginary to image. The meaning of the equality of the complex number is to equate real to real and imaginary to imaginary. So that was the concept of equality of the complex number. On that basis, today I will also send few more questions on that. And I have put it on a question in previous class, that was if x plus iy whole to the power 1 by 3 is equal to a plus ib, then prove that prove that basically it is an example on equality. It's a good example. Prove that x by a plus y by b is equal to 4a square minus b square. This is the question. Now I am just trying to solve it and you just try to get it. Given is x plus iota y whole to the power 1 by 3 is equal to a plus ib. Cubing both sides. What we'll do first? Cubing both sides, it will be x plus iy is equal to a plus ib whole cube. Now this implies x plus iy is equal to a cube, a plus b ka whole cube results will follow up here. A cube plus 3a square ib plus 3a ib whole square, and finally it will be ib whole cube. When we solve this one, x plus iy is equal to a cube plus 3a square b iota plus 3ab square I square plus I cube b cube. Now we'll put the value of these iq and I square. What it will be? X plus iy will be a cube plus 3a square b iota minus 3ab square. Why so? Because we have put it to the value of I square, and earlier we have gone through I square is minus 1, and here IBQ. Why IBQ? Because IQ is a minus I. Now further we'll proceed. This is x plus iy. This is AQ minus 3ab square. We can club like this, the real part, and I am clubbing the other part. This is a square b minus bq. Now by equality, how we can write down? By equality, x is equal to aq minus 3ab square and y will be 3a square b minus bq. What I am doing here, I am just equating the real to real and imaginary to imaginary. Now, what we have to prove? For LHS, we have to prove x by a plus y by b. We'll put the value of x and y. X is, this is a cube minus 3ab square upon a, and y is 3a square b minus bq upon b. Taking common a from numerator, this is the a square minus 3b square, because a will go out, here also b will go out, and it is 3a square minus b square. Now further we'll add, this is 4a square minus 4b square. We'll take 4 common, then it will be a square minus b square, which is RHS. Hence result follows. Hence, hence result follows. This is very important questions on the CBSE level basis. And you just go through that. By doing so, you can develop the sense of working of questions based on equality, and this is very relevant. Let's stop it. Further, I am proceeding with the algebra of the complex number. What does the mean of algebra of the complex number? The meaning of algebra of the complex number, how we'll add it. Add to complex number, addition. Then this is subtraction, and then the multiplication, how we can multiply the two complex number, and division. These are the operations which you have to observe: addition, subtraction, multiplication, and division in terms of the complex number. I'm just proceeding with the addition today, and further we'll go with the other things. Addition. Let Z1 is equal to two complex number, x1 plus iy1, and Z2 is equal to x2 plus iy2. How will add it? Z1 plus Z2. How will do that? This is x1 plus x2 plus I y1 plus y2. What we are doing, what I am doing here, adding real to real and imaginary to imaginary. Example given for that addition, this is Z1 is equal to 2 plus 3i, again I'm repeating, and Z2 is equal to 3 plus 4i. Suppose we are writing like that. How will add it? It's very simple. Z1 plus Z2, that will be the 5, 2 plus 3 together, and 3i plus 4i together, and it will be nothing but is the 5 plus 7 iota. So it is very simple to add the two complex number, to add the real to real and imaginary. Same way we can go with the subtraction. What we'll do in the subtraction, we'll subtract the real to real and imaginary to imaginary. And for multiplication also, what we'll do, we'll go with a simple algebraic multiplication. And for division, what we'll do, we'll go with the rationalization. But I'm not elaborating all these things today. Rather, I'm sticking on the addition only today. And further, I'm putting few questions based on the equality of the complex number and the standard form of the complex number, and what is the real part and how we can denote it. Suppose some complex is like this, zx plus iy, and somebody is asking how will denote it, RE of Z, then RE of Z will be X, again I'm repeating that, and IM of Z, it will be Y. So I'm not moving further, as I have repeated this one. Further we'll go with the properties of the addition of the complex number and multiplication of the complex number. We'll also discuss what is multiplicative inverse, what is additive inverse, but right now I'm binding here, saying all of you, just take care about yourself and do the question slowly. Don't make any panic. If you are not getting anything, call me. If you are having any doubts, any problem in any presentation, you just consult me. Nothing to worry. Just start working. Start working. Thank you. Thank you for today. God bless you.